I'll cover the part 2 of a nuclear chemistry video that was intended to be completed a few days back, but because the previous video had some technical issues and it was 3.5 gigabytes, so it was quite large, so it had to be deleted. So I've decided to now replace that half an hour video with around about 10 minutes worth of final summation, and it'll be far more quicker and easier to understand. So I'd like to go through the 12 reactions I did, the 12 equations of nuclear chemistry that were performed here. I think the first two were covered. We'll move on to the second one, the third one. So in the first one, just to recap, we had beryllium isotope transmuting into beryllium. We had beryllium normal beryllium transmuting into its isotope upon gamma injection, and we were able to use the matrix format to calculate the loss of particulate mass. So the mechanism was gamma bombardment mediated neutron emission. So these were two synchronous processes happening in simultaneity. Number 2 process was the bombardment of alpha particle onto a nitrogen nucleus, leading to the production of protium and oxygen isotope. Now, in many cases, it could be desired, but medical oxygen is not used for physiological support purposes, so it wouldn't be used for patients. However, protium could be this process could be used to generate protium. Again, the efficiency needs to be taken into account. So again, we use the matrix format to calculate the missing masses. And yeah. Now, moving on to question number 3, it was a beryllium being bombarded with a protium, leading to the production of a lithium isotope and an alpha particle. What I did here was I used the matrix format to add these two masses, the nucleonic and the atomic number of these two entities, and subtract the lithium credentials from here to find out what was missing. So the missing item was an alpha particle configuration. So I concluded that protium injection encourages alpha emission with isotope byproduct. Then question number 4 was about a bismuth being bombarded with a deuterium. It seemed like a nuclear hard water reaction in old-styled nuclear generators. So bismuth was being bombarded by a deuterium, leading to the formation of an unknown entity and a protium. So it seems like protium production is quite a common after effect or byproduct. So we knew that the reactant part of the video was pertaining to deuterium bombardment, and the product was an isotope byproduct formation, and along with protium ejection. So the correct spellings for protium are Papa Romeo Oscar Tango Echo Umbrella Mother. So bismuth. So I used the same methodology as here, and I added the reactant's nucleonic masses and subtracted the 1 to find out that the missing part was a 210 and 83, most probably a lead. Now, if I look at the periodic table here, I'll be able to find out that 210 is an isotope of it would be an isotope of bismuth, not lead. So I'd like to cancel it out here, and I saved it for the video. That would be a bismuth. A 21083 would still be a bismuth, because it would be a bismuth isotope. Now, so that's the answer. Now, this question number 5 was about a neutron bombardment on an oxygen isotope undergoing neutron bombardment, controlled bombardment in an isolated incident. that aspect is quite powerful, because if it happened on a critical mass scale, it would lead to quite a lot of detonation propulsion. So case of neutron bombardment leading to alpha emission trajectory. What I did here was I found out that it's a unimolar ratio, 1 mole of oxygen atom being bombarded by 1 mole of neutron, leading to 1 mole of carbon-13 isotope production, and then a Y missing entity. And I used the nucleonic configuration to add the reactants, which was 17 and 8, and I subtracted the carbon's nucleonic configuration with 13 and 6 to give me 4 and 2. So 17 minus 13, 8 minus 6, it gave me 4 and 2, and I know that 4 and 2 always coincides with an alpha particle nucleus, not a helium, but an alpha particle nucleus. Alpha particle, because alpha particle has the same configuration as the helium nucleus, but it's not a helium atom. That's a misconception students come across, experience quite a lot. So they interchange helium and alpha particles. It's not the same. Alpha particles are known as an helium nucleus, but they're not the helium atom. So 16 grams of oxygen with 1 mole of neutrons, which would be 6.02 times 10 to the power 23 part neutrons, would give rise to 13 grams of carbon and 4 grams of alpha particles, which is quite devastating if ingested. Alpha particles have a high ionization density, and they can destroy the tissue if ingested. So question number 6 was about boron. Boron's normal configuration is 11 and 5, but here we can see it's 10 and 5, so it must be an infra isotope. And so boron here, it's been flipped. So what I need to do is to add these first, and then subtract this from this to find out what this and this would be. So I can see here that this was an alpha nucleus. So it was an alpha particle bombardment leading to isotope byproduct production along with neutron emission. So that's also an interesting reaction. Question number 7 was about nitrogen 14, which is normal nitrogen being bombarded with a controlled neutron, leading to formation of isotope and protium. And so I used 14 and 7 plus 1 and 0, that's 15 and 7, and I subtracted 1 and 1 of protium, so that gave me 14 and 6. So that comes out to be carbon. Because we judge by the atomic number, not the nucleonic number, because isotopes are all about changing nucleonic whilst keeping the atomic proton number constants. Then we had question number 8, where fluorine nucleus was being... Remember, all of these are acting at nuclear level and not bothering the electronic configuration at all. It's a change in the number of nucleons, not electrons. So we can see here... fluorine is 19 and 9, so that's a normal fluorine at a nucleus being bombarded by an isolated neutron, leading to the production of an isotope coupled with alpha emission, indirect alpha emission. So 19 and 9 plus 1 and 0, that's 20, and 9 minus 4 and 2, that's 16 and 7, so that gives us... that would give us... that would be 16 and 7. That would be a nitrogen. So that would be a nitrogen again. Thank you very much. That's glad I learned. So that will be a nitrogen. That'll be a nitrogen. Question number 9 pertains to lead. 207 and 82, and it's undergoing beta emission, leading to... so what I did was I let it go, and I added the 1, and it turned out to be 207 and 83. 207 and 83, because when you minus 82 minus 1, it becomes 207 and 83, because 82 minus 1 equals 82 plus 1. So that'll be 207 and 83, and that would be a bismuth. That'd be a bismuth isotope of...
That'd be bismuth proper. So that's, yeah, that's bismuth. No, that's bismuth isotope. Now, question number 10 is about aluminium proper being bombarded by an a neutron that leads to the formation of, you can see they've mixed it up a little bit. And here, these are the missing entities we need to find out. And neutron bombarding aluminium nucleus. So 27 and 13, and so what I did was I added the reactant part. Sorry, that's an Mn reactant, and then I got 28 and 13, and I realized that if it's 28 here, 28 and 13, then this part, so if 24 is here, this part A would be 4, and if 2 is here, then Y must be 11, so 24 and 11. So I found out that it was 24 and 11, and it was a sodium isotope, because sodium, in sodium, it's 11 because this is 11, and had it been 12, then it'd be magnesium. So we judge an isotope by the number of protons and not by the number of nucleons, because nucleons are undergoing variation. So aluminium proper gets bombarded by a neutron, converted into a sodium isotope, coupled with an alpha emission. Now, we've got, in this question, penultimate question, number 11, we've got 37. That's a chlorine isotope, super isotope, and then we've got PAQ and R. Now that's a bit tricky because we've got the missing value here, here, here. So if we use the matrix methodology, matrices, we'll see it's 37 and 17, P and Q, R and 16, and 1 and 1. So it's just a little bit of tricky subtraction addition, and we've got 37 here, and it's 1 here, so it must be 36. 36 and 37, and so 37 and 138, so that'll be 1, P equals 1, Q equals 0, 1 and 0, so we know, and R is 37. So we know that balancing of mass defect leads to nucleonic configuration settlement. We got that. Now, so it was a typical neutron bombardment leading to the production of 37, so that 3716. It was a sulfur. That's sulfur. We know it's a sulfur, so that's a sulfur. That's a sulfur isotope, and the production of protium. So neutron bombardment leading to all of this. I hope you'll be able to see here. So, and then question number 12 is all about lithium isotope, infra isotope, being bombarded by neutron, leading to the emission of an alpha nucleus, helium nucleus, and alpha particle, and then X, an unknown element X. So it's an isolated controlled neutron bombardment, and so if I use the matrix method, I get 6 and 3, 1 and 0, so that's 7 and 3, minus 4 and 2, I get 3 and 1, so that's tritium generation. So that's tritium right there, H3 and 1, that's tritium production, that's a tritium generator. This is how tritium triple water is T2O is generated in nuclear generators. So that's how things are. Thank you very much for watching, and I hope you learnt something about nuclear chemistry and how to manage these radioactive equations, and I hope I was able to get the message across about half-life being a nuclear event with stochastic randomized nature.
Thank you very much. Have a lovely day. Take care. Bye now.